Happy Monday, Precalc kiddos. Today we're going to go ahead and start graphing in 3-dimension. Last week we looked at section 12.1. Everything that we graphed was 2-dimensional, meaning that you had a coordinate plane with an x-axis and a y-axis. The points on the coordinate plane, their location could be described using an ordered pair, x, comma, y. If you have a system of equations that have 3 variables, like we solved last week on Thursday and Friday, where you had those x, y, and z, you can also graph what's called ordered triples, which are x, y, and z in 3-dimensional graphs. And when you have a grid to have x, y, and z, you have to have an x-axis, a y-axis, and a z-axis. And when you put those together, it's called 3-dimensional space. Okay, so again, just to kind of understand how this is working, if it's 2 dimensions, you need your x-axis and your y-axis. You just need the 2. If we are graphing in 3-dimensional space, you need an x-axis, a y-axis, and a z-axis. So if you've never done this before, right now you're probably like, whoa, Becker, what's going on? Because the x is normally side to side and the y is normally up and down. But when it's 3-dimensional, the x, the first value of your ordered triple, is coming forwards. Think of this line as going right towards you, and this is backwards. So if it's positive, you travel forwards. If it's negative, you travel backwards. And that's what the x value tells you. Now y, you're used to y being up and down. Well, now y is side to side. If your y value is positive, you go to the right. If your y value is negative, you go to the left. Now z is up and down. If your z value is positive, you travel up. If your z value is negative, you travel down. So again, your ordered triple is x, y, and z. The first value tells you if you go front or back. The second value tells you if you go right or left. The third value tells you if you go up or down. Now here, you're going to show me the path that you take. So if I am graphing 1, 3, and 4, 1 is positive, so I go forward on the diagonal. 3 is positive, so I head to the right. 4 is positive, so I go up. So just like when you're graphing on a coordinate plane, you do start at that origin. I'm going to travel forward 1 unit, go to the right 3 units, and then go up 4 units. There's my point. That is A. So notice I traveled forward, right, and up. If I'm looking at B, I don't go front or back. I go to the left because it's negative. I don't go up or down. So this is called an intercept. I'm just going to the left 2, and my point ends up on the y-axis. Here's the next one. The first value is positive, so I go forwards on the diagonal. The second value is negative, so I go left. The last value is negative, so I go down. So from the center, I'm going to go forward 2 units, cut over left 2 units, and down 3 units. And again, some of this, you're just estimating, do the best you can to get 2 units to the left and 3 units down. Main thing is, though, show the path. I can see I traveled forward, left, and down, and then label the point. Here's the next one. The x value is negative, so I go backwards on the diagonal. Then I'm traveling to the right because it's positive, followed by down. So here I'm going to go backwards on the diagonal 2 units, go to the right a unit, then down 4 units. So my D point would be somewhere around there. Let's do one more. This is a fun Monday. I like this. -1, it's negative, so back. -3, head to the left. +1, head up. So from here, I'm going to go back 1, cut over to the left 3, and up 1. So that is the first part, is just being able to graph ordered triples. This represents 1 point. Okay, so you're showing the path. Is your point going forwards or backwards? Is it going to the left and the right? Is it going up and down? So make sure you have the path that you're taking. Where you end, you put a coordinate in your 3-dimensional space. Label your, in this case, a variable or letter. I believe in your assignment it's going to be numbers, so you'll have a point and label it 1, 2, 3, 4, and so forth. okay? When you are graphing in 2 dimensions, it takes 2 points to make a line, okay? So you graph your 2 points on a coordinate plane. At that point, you have enough points where you can go ahead, connect them, and call it a line. When we're working in 3 dimensions, the object that we're getting is called a plane, and it takes 3 points. The easiest method of graphing a plane is to find your x, your y, and your z intercepts. Now remember, an intercept, that means that's where the plane is going to touch the x-axis, the y-axis, and the z-axis. In order to find your x-intercept, you're going to plug in a 0 for y and z and solve for x. If you want to find the y-intercept, you plug in a 0 for x and z and solve for y. Okay, so you kind of follow that pattern. Once you find all of your intercepts, you graph them. Now a plane is a 3-dimensional object. So you're going to go ahead and connect them in shade to show that you actually have a figure, not just a few random points. Okay, so if I want to find the x-intercept, what that means is I keep x in, and I'm going to fill in a 0 for y and z. Well, this would cancel, so 2x equals 12. Divide both sides by 2, so x is a 6. Remember, the x-axis is forwards and backwards. This is positive, so on the x I go forwards 1, 2, 3, 4, 5, 6. There is my x-intercept. Now if I want to find the y-intercept, what you're doing is you are changing all of the variables except for y into a 0. If I put in a 0 for x, that term would cancel. If I put in a 0 for z, that would cancel, leaving my equation 3y equals 12. If I divide both sides by 3, I get a 4. So remember, the y-axis now runs side to side. 4 is positive, so I go to the right. 1, 2, 3, 4. That is called your y-intercept. If I want to find the x-intercept, or sorry, we already have x. If I want to find the z, I put in a 0 for x, I put in a 0 for y, and now I have my z. This term cancels because they have a value of 0. My equation is 4z equals 12. Go ahead, divide by 4. Your z-intercept is 3. Z runs up and down, so I go up 1, 2, 3. Now those 3 points form a plane. So you go ahead and connect them, and you show that this is a 3-dimensional figure by shading, and now you just graph the plane. If they ever asked you to show your intercepts as ordered triples, this is what it would look like. Your x-intercept is 6. You got that if you had y and z as zeros. Your y-intercept was 4 when x and z are zeros. Your z-intercept was 3. You got that when x and y were zeros. So if they ask you to write it as an ordered triple, you're going to just take your x value, that goes in the x location. The other 2 are zeros. That's why it's on the x-axis. Your y value would go in the y location. The other 2 are zeros. That's how you keep it on the y-axis. Your z-intercept goes in the z location. The other 2 are zeros to make sure that that point is on the z-axis. One more of those, and that is it for our notes for this fabulous Monday. If I want to go ahead and find the x-intercepts, what I'm doing is putting in a 0 for y and z. So you could just cover them up. Okay, if I put in a 0 for y and a 0 for z, they would become 0. They would cancel. So I would have 3x equals 12. Well, you'd have to divide by 3. 12 divided by 3 is 4. So there's my point as an order triple. I go forward 1, 2, 3, 4. There's my point. If I want to find the y, what I have to do is put in a 0 for x and a 0 for z. So what I have is 6y equals 12. To solve for y, you just divide by 6. 12 divided by 6 is 2. So I don't go forwards or backwards. I go to the right 2. I don't go up or down. If I want to find the z-intercept, you put in a 0 for x, you put in a 0 for y. They would cancel, leaving you 4z equals 12. If I divide by 4, 12 divided by 4 is 3. That's positive, so I go up 1, 2, 3. There are my 3 intercepts. I have the order triples right there. Go ahead and show that it is a 3-dimensional shape. connect them, and shade. That is 12.1a. You will find practice questions in your book on page 794. I would like you to do 1 through 12. Have fun with this. It is kind of a cool topic. I hope you have a great start to your week, and I will talk to you tomorrow.